In the last lesson, we were talking about how to graph sine and cosine. Remember, we have these new parent functions, and we want to be able to transform them. Now, graphing sine and cosine, especially when you start getting a bunch of transformations in these, it is very challenging. Okay, so hang with me here. Those of you who are coming back to see me for trig next year, we'll go back over all of these topics again. Advanced math, you'll do a little bit of it, not a ton, okay? But I understand this is a challenging topic, okay? So stick with us. We'll get this figured out. So remember our transformations, the ones we were dealing with and getting a little bit more comfortable with were these first two. Remember, A tells us the amplitude, and that tells us how high and how low our graph is going. Remember, if A is negative, that's going to reflect our entire graph. B adjusts the period. Now, B is not the period. The period is 360 divided by B, or 2 pi divided by B. Okay, depends on if you're graphing in degrees or radians. H is called the phase shift or the horizontal shift, and that is going to move it left or right. And then K, we call that the vertical shift. I don't know, it doesn't want to write a T there. I don't know why we can't write there. It's very difficult. This is a vertical shift. Which is going to move it up or down. All right, so now we're going to apply a bunch of those to various graphs. Okay, so let's take a look at this next one. We have y equals 3 cosine of x plus pi over 4. So we'll just start filling in our information. Our amplitude is going to be 3. The period, let's do this, since we have pi over 4, let's do this one in radians. The normal period is 2 pi, and we have to divide that by the number that's out here in front of the x, which in this case is just 1. So our period is 2 pi. Our phase shift, that's this number right here. Okay, anything that happens in the parentheses is opposite of what you would expect. So this is going to be left pi over 4. And then vertical shift is anything that's hanging out over here, which we have none. Okay, so I'm going to erase some of this so we can actually see what's going on. So these are the important pieces of information that we have. So let's start working through this. So we have an amplitude of 3. Oh, let's start with this. We have a cosine function. So cosine starts at the crest, and our crest is going to be 3 up. 1, 2, 3. But our crest has also been shifted left pi over 4. So we're going to have to move that to negative pi over 4. Okay. Now, normally, we would get through our period in 2 pi, but that has also been shifted left. Okay. So now, since we're in pi over 4, I'm going to do pi over 4 for our increments. So pi over 4, and then 2 pi over 4, which reduces, and then 3 pi over 4, and then 4 pi over 4. I'm going to make this longer. 5 pi over 4, 6 pi over 4 reduces, 7 pi over 4, and 8 pi over 4. Okay, so normally our next crest would be at 2 pi, but that has also been shifted left pi over 4. So we're there. Now, normally our bottom point would happen halfway between 0 and 2 pi, so normally it would happen at pi, but that's been shifted left pi over 4. So our bottom point is going to be here. And then halfway between these is where we're going to hit this midline. So I think here and here. Okay. So this is what that cosine looks like. Okay. Very, very similar to the cosine graph that we had before. It's just everything has been shifted left, pi over 4. Our domain is still going to be all real numbers. Our range is still from -3 to 3. All right, let's try another one of these. We'll do this one in degrees, because we haven't done one in degrees yet today. So let's fill in the information. Our amplitude is 2. Now the period is 360 divided by b. B is the number in front of the x, which in this case is 1/2. So our period is going to be 720 degrees. The phase shift is whatever's in parentheses with the x. So in this case, we don't have a phase shift. And the vertical shift is up 3. All right, so those are what we have to work with. So we are starting with a sine function. A sine function starts at the origin, but remember our origin has been shifted up 3. So we're actually starting here. When we have a vertical shift, I want you to think about this as the new x-axis. So our midline has just shifted up 3. All right, how long is it going to take us to get through, I remember that up, back, that thing? How long is it going to take us to get to this point? And the answer is our period, 720. Okay, I'm going to erase that because that wasn't super good. And that means halfway between at 360, we will hit that midline. And that means halfway between here at 180, we'll hit our top and bottom. Okay, now the one other thing we have is our amplitude is 2. That amplitude happens from the midline. So from this point, we're up 2 and down 2 from this. Okay, so that's what this sine function looks like. And the same thing would happen in the other direction. So if you wanted to go out to -720, you can get the rest of that. Okay, it didn't ask for a domain and range, but the domain would be all real numbers. And notice the range is different here. It is going from 1 to 1, 2, 3, 4, 5. Okay, so because we shifted that up 3, things are a little bit different on this one. We'll do one last of these and then get on with our lives. All right, so we're going to pull out our necessary information. Our amplitude is 3, but notice it's a negative, so it's been reflected. Our period, since we have a pi over 2, we're going to have to do this one in radians. So our period is 2 pi, and we need to divide that by the number that's out here in front of x, which is a 1 in this case. So our period is just 2 pi. Our phase shift is in here in the parentheses. That's opposite of what you would expect. So we're shifting left, pi over 2. And our vertical shift is this number here. We're going down 2. All right. Now, often when I start graphing these, I work from the bottom information up. So vertical shift is down 2. That means we're taking this entire graph, moving it down 2. We have a new midline, so I'm going to start with that. We're shifting everything left pi over 2. So normally the sine function starts at the origin, but we're going to shift that left pi over 2. And remember, we're now down here at this midline, so this is our new origin point. Now, normally we would get through this whole cycle in 2 pi, so here's 2 pi. But that has also been shifted left pi over 2. So here it is at 3 pi over 2. And a sine function, remember, a sine function's up and back like this, so this middle point that I'm looking for is going to happen halfway between these two things. So it looks like that's at pi over 2. And then we're going up 3. and down 3 from this. But remember, it's reflected. So instead of starting on its upward slope, we're starting down. So we're heading down first. So we're going to go from this midline down 3. And then from that midline up 3. 1, 2, 3. Here. So that's what this looks like. Okay, lots of stuff happening in this graph. And it didn't ask us for the domain and range, but we can tell it anyway. Domain is always all real numbers. And the range for this one is, let's see, 1, 2, 3, 4, 5, from -5 to +1. Okay, so I know these are very challenging to graph. I want to make sure that you are good pulling out all of this information. Okay, that's really going to be key. And then these do just take practice. So check out the activities and the homework and just work through those. I don't expect absolute perfection on these. This is a hard topic, even when we're face to face. So, but make sure you're able to look through this stuff. Remember all of these shifts for the sine and cosine graphs.